Hello everyone, we're going to be learning about loops today. Specifically, we're going to be learning about while loops and for loops. These are kinds of iterative statements. The topic we're going to discuss today, loops, is actually very complex. It's not very easy to get your head around the first few times you're learning about it. I highly encourage you to watch this video a couple of times to really let it sink in and to program along with all the examples. You might still have questions, but the easiest way to clarify those is by trying to program using these loops, as well as Googling any questions you may have, and you are always encouraged to send us any questions, concerns, or any requests for further clarification that you'd like or you may have. Okay, so far all the code we've done in this semester has been very linear. Has been a single straight line through a program, and up here we have a flowchart of what the average program that we've been making has. So let's try to go through it real quick. Let me take out the laser pointer tool. So obviously all programs have to have a start and a finish. Now every program we've had has just been, a single straight line through the program, just a one-shot line from beginning to end. If you were to select which options you were going to go through in this flowchart, you would be able to lay it in a single line, a single straight line. Now, this has been great, and we've been able to do some pretty interesting programs so far using this, but is that enough to program every single thing we need? Like, think for a second and think, would there be a moment where we would want to take a path other than a straight line through a program? Maybe we want to, do a little bit of zigzagging. Maybe we want to loop. Maybe we want to just go in a different path. The main concern is that would we have to do that to make all types of programs, or could we make any program that you could conceive of using the straight line program flow? So I'm going to give you a quick moment to think about this. Just think of all the programs you've done. Think, have they all been in a straight line? Is a straight line the best way to make those? Or could there be a better way to make those programs? And think of programs that you haven't even made yet. Just think of something that you could program someday. Would that be better suited to another type of flow, or would it be better suited to a straight line flow? Would straight line be enough for any program that you could create? So my answer to that question is no. There will be programs where you have to take another path other than a straight line. Specifically, there will be times where you will have to loop in a program. So I like to call this loopy program flow versus linear program flow. So if we take a look at this flow chart, let me get the laser pointer. It has a start and a finish just like the other one, but here we're going to have some error correction. We're going to ask the user for an input first, then we're going to verify is this input correct or not, and if it is not, we're going to print fail, but then we're going to go back earlier in the flowchart. See, this is a loop. This is not a line anymore, because now we're going back, onto ourselves in this flowchart. This adds a significantly useful tool to our toolbox, being able to loop in a program, because it makes it so that we can condense code, very easily, make our code size much smaller, and be able to write really powerful programs with very few lines of code. But the really important question is this possible in Python? Have we written loops already? And if we haven't, how can we do that if it is possible? So the answer is yes, we can do loops in Python. And now we really have to define what loops are. So as you can see on the screen, so a loop's a control structure that gives you the ability to replay sort of a specific section of code depending on whether or not a condition is met. They are extremely similar to if statements. If you guys remember, if statements are just a block of code that executes depending on whether or not a condition is met. Well, a loop is very similar to that. However, instead of only executing once or none, it'll execute however many times that condition is still true. Now, there are several different types of ways that looping can be implemented in Python, and we'll discuss that in the next slide. But I just want to reiterate that loops, they follow the same general logic that if statements do. And by now, you're an expert in if statements, right? So if statements, they have their condition, and then after that, they have their block of code. If that condition is true, that block of code executes, and then the program continues after. In loops, the same general format is still there. There's a condition, there's a block. But instead of after the block is executed, the program keeps going, the block restarts until that that condition is no longer met. We'll go into much more details into how exactly these work in the next few slides, but I really want you to understand the similarity here between if statement and loops, because as you go further into into your programming, career, you will learn that a lot of stuff builds off earlier stuff, and when you learn one thing, it'll make learning another thing much easier. So in Python, there's two types of loops that you can create. To be more specific, there's two types of explicit loops you can make. There are other ways you can do some sort of looping in Python, but they're not as explicit, and those will be discussed later on. But for now, we have to worry about two types of loops: while loops and for loops. Now, both of these can be used to implement any sort of looping. However, while loops and for loops are better suited for different tasks. There are tasks that are much easier to implement using a for loop than a while loop, and vice versa. But any looping behavior can be implemented with any of these. As you program more in Python and gain more experience, you'll get a better feel of when to use a for loop versus a while loop, and when to use a while loop versus a for loop. Alright, so first up, we're going to talk about while loops. This is probably one of the most common types of loops across all programming languages. In Python, it provides most control to the programmer directly. We'll learn about for loops in a second. For loops are a lot smarter, you could say, than while loops. While loops, you have to be a lot more explicit with them versus for loops. Now, they are very, very similar to if statements. Down there, you have the format and structure of a while loop. You can see that you type while, followed by the condition, colon, and then under that, and indented one layer in, you have the block of code that's going to run while that condition is true. That block of code will continue running as long as that condition is true. It can run forever if the condition never becomes false, or it can run until that condition becomes false. So let's look at a quick example of a while loop. This is what a while loop would look like if you're writing some code. We have a variable named I that we set to 0. And then the while loop begins. We have a condition that says that as long as I is less than 10, do something. And then inside that while loop, the code block that is within that while loop prints out a statement that just displays what the value of I is, and then we increase the value of I by 1. Now, is this what actually happens? Is this what will happen when we run it? Think of what I've said so far about while loops and how they behave. Is the way that I just described this code block the correct way? Is that what is actually going to happen? Let's check. Let's just put this into the IDE and check if this is what actually happens. All right, so I have Ripple open here. I'm just gonna retype the code that I showed in the slide. So it started with I being set equal to 0. Then the while loop began, so we type while followed by the condition, which was I less than 10. Then you have to do the colon, that part's important, and then we type the code block that we want to repeat. So we wanted to print out the value of I is, and then str to convert it to a string, I, and then we do I equals I plus 1. Now this is the code that we have in the slide, but will this work the way I described it? Let's see. So if we run it, we print out values all the way from 0 to 9. Why from 0 to 9? Why not from 0 to 10? So if we look at this, look specifically at the condition. It says while I is less than 10. not while I is less than or equal to 10. So by the time that I becomes 10, which is here on the 10th iteration, the condition is checked, and then since it is now false, the block is skipped and the code continues. So let me do another print statement so you can see the while loop is now over. Print the final value of I is str I. Alright, now we run it. So as you can see, once the condition was no longer met, which happened right after this print statement, the I was incremented to 10, so this condition is no longer met. The code continues running afterward. So if we had if statements or another while loop or something after, then that would have been executed. In this case, I had 2 print statements, so that is what is executed. Now, while loops can be a lot more complex than this. Just like in if statements, where we could have a bunch of separate conditions, you could do the same with while loops. You can have a bunch of and or statements in there. But this is a really quick example that shows you how a while loop works. What I highly suggest is that you go through manually and think and just write it down. Do the while loop in your head. So I set it to 3 so it's quicker. And when this happens, let's just go through it together. So when the program starts, I is equal to 0. We go into the while loop, and the condition is as long as I is less than 3, then we do stuff. So it's currently 0, right? So it is less than 3, so we go in, we print out the value, which is 0. That's this first line. And then we increment I. Now I is equal to 1. So we check the condition, and we're at the end of the while loop, so we check the condition again. I is less than 3, so I is 1, 1 is less than 3, that is true. So we go back in, so we print it out. The value of I is 1, that is this line here. Then we increment I to 2, so now I is 2, and now we finish the while loop again. We finish that iteration. Every single run of a loop is called an iteration. So we finish that iteration. And now I is 2. So we check the condition once more. I is less than 3. 2 is less than 3. That is true. So we go in again. We print out the value of I is 2. That is this one. And then we increment I again. Now I is 3. Now we check the condition again since we finished that iteration. And we do I is less than 3. 3 is less than 3. That is not true. 3 is not less than 3. So it is false, so we are done. We pick up here. We skip the while loop, we keep going down here. And that's where we print that the while loop is over, and we print out the final value. Something you need to understand, if you have a code like a while loop like this, where you have less than X number, and you increment it each time, after that while loop is over, the value, the variable you were incrementing will reach that final number. Like as you can see here, I went up to 3, within the while loop, I only printed up to 2, but I became 3 afterwards, so you can see it down here. So that's something to keep in mind. This is a very, very brief example of what a while loop looks like in use. I'm going to show you what a cool while loop application is in the next slide. Okay, so here's a while loop application. You could use a while loop as like a control mechanism to prevent a program or function from finishing until a certain condition is met. So this is like how while loops are used, but expanded extremely. Like this function will not finish until that while loop condition is no longer being met. And in this case, this function, all it does is that it asks the user for a string of numbers, and then it determines which one's the largest one, and then it displays it to the user. We're using a while loop in this case to know that the user still wants to provide more information. Now I'm going to show you guys how this function actually works. Okay, so I've typed in the highest value function into REPL from the PowerPoint. So the function, once we look through it, all it's doing is that it's determining which is the highest value provided to the function by the user, and then just displaying what it is and returning it. Now, since this function doesn't have a parameter list, we can just call it by just, you know, writing an empty parameter list. Now, if we were to run this function now, it'll ask us for a number. So let's enter, you know, 42. Let's enter 1, 20, 49, and then -1 to stop. So we know that the max here should be 49. So let's see if that's what we get. And that is what we get. Now let's run it again and see what happens when the first number is the highest one. So 400, 300, 212, 10, and then -1. We got it, we got it. So now let's see if the middle value is the biggest one. So let's do 1000, 9001, and then 7, and then -1. And we still getting it right. See, this is how you should be testing your code. You should think of all of the possibilities to make sure it's working. Now, in the code, the while loop is only used to determine if we are done collecting data or not, which is a good way. This could be expanded out. You could use a while loop to determine if your program should end or not. That is also a common way to do it. But this is just a really brief example of a while loop application. Again, while loops are very powerful and they allow you to do really, really cool stuff. But this is just to get started, something to really sink your teeth into. A good way to test your knowledge is try to modify this function to return the lowest value instead of the highest value. That would be a good good exercise. Okay, so quick quiz time. I've written this function here. What does this function do? Alright, so the function's called count up to n. We give it variable n. We set I equal to 0, then we enter a for loop that happens as long as I is less than n, and we print out what number we're currently at. So that is what we get from reading it. Is that what actually happens? So I want you to think through this for a second. Read through it, think about it, and kind of run through it in your head, line by line, to see what happens. Now I'm going to open up Ripple and then we'll run it ourselves, but I just wanted you guys to have a quick moment to think about what this function is actually doing. Alright, so we're back in the Ripple file, and I have written the function as well as added a call to the function using 10. Now before I run this, what do you think is going to happen when we call this function using 10? Alright, so let's run it, let's see what happens. Okay, not expecting that. So what just happened? Let's think. We apparently got a seemingly infinite number of, we are currently at 0. But that's not right, we're counting up 2. Shouldn't we have 0, 1, 2, 3, 4, 5, all the way up to 10, and then we're done? Well, if we look back at the code, we never updated we never updated I. That never happened. So when we go into the loop, what ends up happening is this: I equals 0, while I is less than n. In this case, it's 10. Print out, we are currently at I. And the while loop's over. So we check the condition again. While I is less than n, while 0 is less than 10, keep going. And then we print it out again. And then the loop's over. So we have to go up to the beginning. While I is less than n, while 0 is less than 10, and then just keeps looping forever. You have to be very careful with your loops. You have to make sure that your loops, you're updating the variables that decide whether or not you leave. The correct way to print this out, the correct way to write this function would have been to add a statement that increments it. Now if we were to run it, we get what we expect, counting from 0 up to 9. But this is a very, very important part of learning loops, and it's something that everybody messes up. I messed it up when I was learning loops the first time, and if sometimes I'm not careful when coding, and I still mess it up as we speak. You have to make sure that the variable that controls your loop is being updated properly, so that the loop functions as intended, and you don't get stuck in situations like this where you have an infinite loop. So now we start talking a little bit about loops, specifically while loops. It's time to talk about some control flow statements, as I like to call them. These are statements that alter the flow of a loop. there's there's two of these types of statements. There's the break statement and the continue statement, and we'll go into these in depth in the next few slides. But these two statements allow you to have certain cases where you make the loop run differently than it normally does. First up, we're going to talk about the break statement. So a break statement will cause a loop to stop. To finish, we are done whenever it is encountered. You normally use it when you want to exit a loop early due to some sort of condition being met. On the lower side of the screen, you have an example of a break statement in use. So that loop would normally run forever because the while statement is just true, and true is true is always true. So that statement will run forever if it weren't for that break statement at the bottom. That break statement will be encountered if I is greater than 10. So what this will end up printing is numbers all the way from 0 to 10. And then once I is greater than 10, once I is 11, the if statement will be entered and that break will be encountered. And once that break is encountered, the while loop is exited permanently. It is not restarted. You just leave it. It's as if encountering a break statement makes it so that the condition is no longer true. That's not what happens because the condition is no longer suddenly false. It just makes it so that the condition is ignored and then it is treated as false so that the while loop instantly ends. It doesn't finish the current iteration either. It just ends where it's currently at. It doesn't do anything after the break statement within the loop. It doesn't restart. It just ends and the code picks up after the while loop. Now let's actually see this in action in Ripple. Alright, so I've copied over the code block from the PowerPoint over to here. I've also modified it a little bit because I wanna showcase a couple of things. I added a print statement at the very start of the while loop, and I've also added a print statement at the very end of the while loop. So you can see how I is updated midway through every iteration instead of at the exact start or at the exact end. I've also added a little print statement here so we can see when we're breaking out, and a print statement after the while loop so we can see when we've broken out of the while loop. So let's read this through line by line first. So I is equal to 0. That's how I is initialized. Then we enter the while loop. The while loop says that as long as its condition is true, then we continue. The condition is just explicitly true. It will always be true. So unless we do something within the while loop to bypass the condition, we will always be stuck here. So let's start. So if we go into the while loop, the first thing we do is we print out the value of I. Then we increment I. Then we check is I greater than 10. If it is, we print out the statement and we break. If we don't go inside this if statement, the code just picks up down here and we just print out the final value of I in this iteration. Now, normally after an if statement is done, the code picks up after the if statement. But remember, this break will cause us to leave the while loop entirely from where we are at. And then after the while loop completes its executions, then we just print that out. So let's run it. Let's see if this is what actually happens. And yeah, that's what happens. So when we first go into the while loop, the first iteration, I is 0. When we go in, that is correct. We incremented. Now it is 1. We don't go into the if statement, and then we print out the new value. And then we start over again. Now this holds until I is 10. So if we pick up here, at the start of this iteration, I is 9. Then I is immediately incremented to 10. Is I greater than 10? It is currently not. So we're good. And then we skip this if statement, and then we print this statement out, saying that I is now 10. So now we restart over, and we print out that at the start of this iteration, I is 10. We increment it. Now I is 11, and now if 11 is greater than 10, which it is, we go in here, we print, I've got to break free, and then we break. And when we break, we just jump straight down here. We don't print out at the end of this iteration. We just jump out immediately. This can make your code very powerful because this allows your code to implement while loops that you can escape out of early if you need to. Let's say you ran into an error and you want this while loop to stop now to not cause any damage to the program. Then you would do a break statement. Maybe you want to use a break statement to know when the user has finished putting in all their inputs. You could use a break statement for that. Break statement is very powerful. It's a simple statement, very easy to understand, but it adds a lot of complexity to the kinds of loops you can implement. So like I just mentioned, you can use while statements to determine if a user has finished doing inputs. So I modified the function we used earlier to use a break statement instead of just exiting using the while loops condition. So this function works the exact same way as the function I showed you guys earlier. Now I'm not going to run it in this video to save time, but what I want you guys to do, I want you to write this code, this program, this function, and call it on your own Python IDE, so you can see that it is actually working the way that it is intended to work. So the other type of control flow statements are called continue statements. They're similar to break statements, but instead of finishing the overall execution of the loop, it finishes the current iteration. It makes it so that the iteration is terminated, but instead of exiting out of a loop, it just restarts the iteration as if a normal iteration ended. It's much easier to see a continuing action to understand it, so let's just do that really quick. This is a application of how continue would work. So this function, all it does is the user provides a bunch of numbers, and we check if the number provided is even or not, and then every time we find an even number, we say that we found an even number, and then at the end, when the user is finished inputting all the numbers they're going to input, we just say how many even numbers we found. So let me just get this over on Ripple, and then we could talk about it a little bit more in depth. Alright, so I have the function over here in Ripple. Now let's just call the function so that we can see how it works, and I can just talk about it as we run it. So when we run the function, the first thing that's going to happen is, oh, let me run it again. Oh, I see what happened. This is actually a good learning moment. Do you see what the issue is right now? So the issue with this code is that I typed in how many even indented, which means that this code is actually part of this function. What I was supposed to do, I should have just made sure it was in the proper indentation. Now if we run it again, it'll work properly. So that's a good learning moment. We'll just say it was on purpose, even though it wasn't. We'll just say it was. So now when we enter a number, let's enter 1, nothing happens. But we enter 2, 2 is even, so we print out that message. And we enter 3, nothing happens. 4, that's even. 5, 6, 7, 8, 9, and then we do 10. See, those are, so we got a good spread there. Now if we look at the code, what ends up happening is that while the current value is not -1, that's just used to get all the values we want, we get the current value that the user submitted. We check if that value is even, and the way we check it's even is that we use the modulus operator, which is the remainder operation, and we determine if when you divide by 2, is there a remainder left or not. This is checking if when you divide by 2 there is a remainder left, the remainder is not 0, then we know that number. I apologize. Let me read through that again. I might have said it wrong. What this if statement does is that it takes the current value, divides it by 2, and checks if there was a remainder. If there was a remainder, that means that the number is not even. If the number is not even, then we don't care about it. We don't want to do any calculations. There's no need to print. We're done. Let's go to the next number. And the way we do that is by doing continue. When continue is called, the rest of the loop is completely ignored, and we just restart up here. See, we don't exit out. So let me do another odd number, 3. See, we didn't exit out. We went up here again. We restarted the while loop, and then we just kept going. Now let me do -1. So -1 was used to exit out of the while loop. Now it says there were 5 numbers. Let's see. Let's count them out. 1, 2, 3, 4, 5. Yeah. So there were 5. Now the continue statement can be thought of as like a skip. So let's skip this iteration and start over, and start the next one. The break can be thought of as a stop. We are done. I don't want to do this while loop anymore. I wanna get out. I don't want to do this looping nonsense anymore. Whereas the continue is a skip. It's like a fast forward. Like, all right, I don't want to do the rest of this iteration. I want to start the next iteration up. Which is both of these are very useful, very powerful tools that will allow you to make really cool looping programs and add really interesting logic to your code. Alright, so now that we talked a lot about while loops, we need to talk about the other type of loop that we mentioned earlier in this video. We talked about, we mentioned for loops. Now it's time to talk about for loops. So, for loops, like while loops, are a looping structure, but they behave very differently. In Python, for loops are used to iterate through through something that could be iterated upon instead of just a regular looping mechanism. Almost all other languages have their for loop be very similar to the while loop with a little bit more structure, whereas in Python for loops are mechanically very different to while loops, but in terms of behavior, they behave in the same way. They give less control to the programmer, but they are much smarter. They can do a lot of stuff in a single line that would take several lines of code in a while loop to be accomplished. So they can be thought of as the smart loops, where they do a bunch of stuff for you without you having to be really explicit about it, whereas the while loops are dumb loops and you have to be really explicit about what you want to do. Sometimes being able to be explicit is good, and sometimes it's not. So it really depends on the circumstances whether or not you use a for loop or a while loop. Alright, so before we go too in depth into how for loops work, we need to talk about what iterating is. So iterating is the action upon going through an object that can be iterated upon. Now that sounds like I just said a bunch of nothing, but if we look a bit deeper into that, so let's look at the second line. Second line I think describes it a bit better. Iterating through an object means that you're going to go through every single part of that object in something like a loop. So for example, if you iterate through the string hello, that means you're going to go through each letter of the string in a loop type thing. So you're going to go through H, then E, then L, then L, then O, and then you're done. So that's what iterating is. It means you're going through all of the parts of something. We just need to make sure that's clear because for loops in Python are used to iterate. So we need to make sure we're understanding what iterating is. Okay, so there's a bunch of different ways you could use for loops, but in all of them you are iterating through something, right? Right now we're going to show you guys how to do for loops using the range function. And the range function, like the name says, creates a range of values, and then with these range of values you can iterate through them, sort of creating a while loop that goes through these numbers. Now the range function can be called in one of two ways. Both of them are displayed on the screen. You can call it with 3 parameters for start, stop, and step, where start is the value you're going to start at, stop is the value you're going to stop at, and then step is by how much the counter should increase each time. If you don't include the step parameter, then the step will just automatically be 1. Now for example, if we call range with 5 as a start and 10 as a stop, range is going to go through 5, 6, 7, 8, 9. It's not going to reach 10. If you were to call range with a step of 2, so we use start 5, step 2, and then stop 10. We would start at 5, then we go to 7 because we go up by 2, then we go to 9, and then we stop because the next step would have us over 10. That is how the range function works. 99% of the time, you're going to be using the second one, just start and stop. You're usually going to want to go up by a step of one, which is implicitly implied when you do just a two parameter range. Okay, so this is an example of how the for loop looks like in code with the range example. So I'm going to put this in Ripple really quick so that we can talk about it a bit more in depth over there. All right, so I'd copied over the print hello world n function. So if we call print hello world n with let's say 10, what's going to happen is we're going to run it and we're going to get 10 hello worlds. Now let's look closely at this. So the way a for loop looks like, the format, which we're going to go a little bit more in depth in the next slide, but I feel that specifically with the for loops, it's better to see it in action first before we really start breaking down the structure of it. So we have for x in range 0 up to n. So as we discussed earlier, this means that we're going to have a range from 0 all the way up to, but not including n. And then the x is going to iterate through this range. So x is going to become 0, then 1, then 2, then 3, then 4 on each iteration of this loop. That means that as we are printing, we first print 0, 1, 2, 3, 4, 5, all the way up to n. Because we increment by 1, that means we go from 1 up to n instead of from 0 up to n minus 1. So if we were to do 3, we're going to have hello world 1, 2, 3. And that's what happens if we were to have 100, 1,000. We're going to get 1,000 of them, which is pretty cool. Now this is the basics of how a for loop works. This is going to get a lot more complex because you don't just have to iterate over a range. You can iterate over other types of cool things that we'll go over in a second. Alright, so this is the for loop format. Let's just go through it, piece by piece. Let me get the laser pointer out. So first you have the for keyword, like while loops and if statements. You have to write what it is first. And then we have a variable. Now whatever this variable is, whatever you end up putting here, this variable will hold the value of each individual piece of the iterable object you end up using. After that variable, you have the in keyword. This part is necessary. And then you have iterable object, whether it be a range or a list or any sort of object that can be iterated upon. The variable will go through every single part of it. Now in the previous example, the variable was x and the iterable object was a range, which meant that x went through every single piece of that range. So from 0 up to 9 if we picked a range from 0 to 10. While the for loop is occurring, this block of code will execute. So it will execute so long as there's still iterations left to do. So in the range, this block of code kept going up until the range was exhausted. So it's kind of different in the sense that there's no individual condition that decides if it is true or not, but it is the same in the term as a while loop in the terms that it will repeat a block of code over and over again for a certain amount of time. So as I previously mentioned, for loops can be used with strings. Strings are an object that can be iterated upon. So for loops can iterate a bunch of different objects. Like they can iterate through lists, dictionaries, tuples, and a bunch of other objects. We'll see a couple of these types of objects in this course, but there's just an extremely large amount of objects that can be iterated upon, and you can make your own. Once we get to that stage in this class, you will be able to make your own objects and then make them iterable, which is pretty cool. Alright, so now this is a code example that shows how a for loop can be used with a string, how you can iterate through a string to do something. So what this function does is that you provide it with a string and then you start a for loop where x is going to iterate upon user string. And then what x is going to do, it's just going to print out each letter of it's going to be each letter of the of user string, and then in each iteration we're going to be printing out each letter individually. So let's get this over on Ripple and then let's try it. Okay, so I copied over the function over on Ripple, and let's just call it. So if we call spell out, and let's say we use my name Jan, and we call it, then all that's going to happen is that X is going to iterate through Jan, and all the individual parts of Jan are going to be Jan, and then in each iteration it's just going to print out the letter it currently is. So X becomes each part of user string throughout all of its iterations. And this will work with any sort of string. Like let's try Luke. If we try Luke, it'll print out Luke. Let's try, Anakin Skywalker. And it'll print it out. And then we could any string, it'll go through all of its parts. So Gabe Newell, it'll print it out. The quick brown fox jumps over the lazy dog. Print that out. We'll just get all of the individual parts. So this can be done with any iterable object, but for now, it can be done with range to go from one number to another. It can be done using strings, and then once we cover lists, and you learn what lists are, you can also do it in lists, which is pretty cool. So now we need to talk about something called nested loops. Sometimes in programming it is very useful to nest a loop within another loop. Now what this means is that you're going to have a huge loop, and then within it you're going to have like a smaller loop. Now this is called a nested loop. It is very similar to nested if-else statements, which can be done as well. You can have an if statement, and then within that if statement have another if statement. But with loops it gets a bit more complex, because if you have a nested statement, the outer loop may executes once. It performs one iteration per the inner loop performing all of its iterations. So before the outer loop can go to the next iteration, the inner loop must completely execute within it. Now, loops can be nested infinitely, but it is very, 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 I cannot emphasize this enough. It is very rare to go above 1 or 2 levels of nesting. So like if you have a while loop within a while loop within a while loop, anything over that, there's probably a better way to do it. Even a while loop within a while loop, that's probably as far as like 99% of solutions will require. If you have 3 nested while loops, stop and think if your solution can be implemented in a different way, because it is very, very rare for something to require more than 1 level, more than 2 levels of nesting. Alright, so this is an example of a function that uses nested for loops to implement its functionality. All it does is just prints a rectangle given the rows and the columns. Let's get this on Ripple so that we can really dig into it. Alright, so I have the function here in Ripple, and if we look at it closely, you'll notice that we need to give it the row and the columns, and then we have 2 for loops, one where we go from the range from 0 up to row, and then within that we do from y up to column. Now, you have to really think about this, because this means that the second for loop executes entirely. It performs all of its iterations every time the outer for loop does a single iteration. Now, you might be a bit confused about what this print statement's doing. Don't worry too much about it. All this is doing, it's saying that instead of the print having a new line at the end, it should have nothing. You know how normally when you do a print statement, it's its own line? If you do this, it makes it so that it is not its own line, so that the next print statement just happens right next to it. But let's run this. Let's see. Let's make a rectangle that is that has 2 rows and 5 columns. All right, so let's run it. And yeah, so that is 2 rows, 5 columns. Now let's say we want 5 rows, 5 columns. All right, so let's count them out. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. That is correct. So we have the so this is definitely working, and the only way it works in a way that makes sense is by using nested loops. So this just shows you that you can do some pretty cool stuff with very little code if you do nested loops. Like I could make a huge, let's see if I can do 100 by, well not 100, let's say 50 by 50, or if Ripple will scream at me. That's pretty cool. So you can make a huge rectangle using this. And you don't just have to make rectangles. If you add additional logic to this, you can make circles, you can make triangles, you can print out like a star. You can do some pretty cool stuff doing using nested for loops. Um, Also, this doesn't have to be with for loops. You can use while loops. Throughout this lecture, we talked about a lot of loop concepts. All of the loop concepts apply to both for loops and while loops. I can use continue and break in a for loop just the same way I can use them in a while loop. And I could use nested while loops just the same way I could use for loops. But I just want to show you guys this quick example of how a for loop a nested for loop can happen. This could also have been implemented using a nested while loop. It just would have required more code because I would have had to create variables and then and then increment those variables myself, and then it would have been more lines of code. So you can see how in a for loop this is a much more efficient way to do it. I would like to challenge you to write this exact function using a while statement instead of for loops. This will give you a really good understanding of how it works. Okay, so that's pretty much everything I have for you guys today. So real quick, to wrap things up, I want you guys to code as much as you can. Like everything you guys have learned in the last few weeks, I want you guys to just make stuff, do things. And rewatch all of these videos as you need to watch them. Look up stuff. Whenever you have a quick question, just Google it, because I can guarantee someone had the exact same question at some point when it comes to programming. Now, if you have any other questions that you want to really in-depth answers or just answers from us, please send them over to the email that's on the screen. And again, this is a learning process, like I mentioned in the first video, so we are learning with you guys, and you guys are learning with us. So I wish you guys the best of luck, and I would keep an eye out for the next video, because specifically the next video is going to discuss a topic that is very useful to use with loops. So that'll be a really good application of what you learned in this video.